Hi everyone, this video is an exercise 11K question 6. So we have a bathtub which is modeled as a cuboid with a base area of 6,000 centimeters squared, and water flows into the bathtub from a tap at a rate of 12,000 centimeters squared per minute. And then at 20 minutes, we have the depth of the water in the bathtub, which is h centimeter. And finally, water leaves the bottom of the bath through an open plug hole at a rate of 500 h centimeters cube per minute. Okay, so we have a lot of things going on, and in part A, we want to show that 10 minutes after the tap has been opened, then we'll have this differential equation. Okay, so in this modeling question, the best thing is just having a very simple diagram at the beginning. So maybe we can start with a cuboid because that's what the question is about. So first of all, remember that according to the question, the base area of this cuboid is 6,000 centimeters squared. And remember that if you want to find the volume of a cuboid, you basically do length times width times height. And in this case, the volume is actually equal to 6,000 h, right? Because h is just the height. And now this is going to be important. Also, another thing is that water flows into the bathtub at a rate of 12,000 centimeters cube per minute. Now that means that dV by dH is equal to, I meant dV by dt, because we are talking about the rate of change of the volume with respect to the time. So that's equal to the inflow of water minus the outflow, right? And in this case, the inflow is just this 12,000 centimeters cube per minute. But also we have a rate for the outflow. So that's here. So water leaves the bottom of the bath at a rate of 500 h centimeters cube per minute. So the outflow is 500 h centimeters cube per minute. Now with that said, we can substitute them into this equation. So dV by dt, which is again the rate of change of the volume, is equal to the inflow, which is simply 12,000 minus the outflow. So remember, the outflow is 500 h, so that depends on the height. Okay, now another thing here is that we want to show that basically this differential equation holds, and this one requires us to have dH by dt. So we basically need to find an expression for dH by dt. And remember that we have dV by dt, so that's going to be helpful because in questions like this, you need to, when you want to form a differential equation and you have multiple rates, you want to use the chain rule. And that's the sort of chain rule that you have in the differential equation context. So in this case, we have dH by dt, and remember that this rate has dt in the denominator. So for the next one, we want to get dH in the numerator, so we want to have that, and dV is the quantity that basically has to be cancelled. So if you have dH by dV, then the dV's will cancel, and then we'll just have dH by dt. And that means that we need to also calculate dH by dV so that we can substitute them into the formula, because we've already found an expression for dV by dt. But the interesting thing is that we have this relationship here that V is equal to 6,000 h, and this is again just the volume of the cuboid, so very simple. And we can differentiate this with respect to h which is just 6,000. And remember that we wanted to find dh by dv, but now we have dv by dh. So we can basically do this dh by dv, which becomes 1 over 6,000. So we are allowed to use this technique in this question, and A-level questions, I mean. And now we have everything to substitute into this formula. So dh by dt is equal to 12,000 minus 500h times 1 over 6,000. So now we just need to simplify this. First, we can divide everything by 100. I mean, not dividing by 100, but when you multiply this, the two zeros of this denominator will cancel out with the two zeros of these terms. So we'll get 100 and, let's write this as 1 over 60 times 120 minus 5h. And remember that the form that we want is having 60 on the other side. So we can just multiply by 60, and we'll get 60 dh by dt is equal to 120 minus 5h. That's exactly the form that we wanted to get. Now for the next part, we want to find the value of t when h is equal to 10 centimeters, and also we are given this initial condition. Okay, so this one is just purely solving the differential equation and then finding that value. So in this differential equation, we can basically divide both sides by 120 minus 5h first, because here depends on h and the h is on the left. So we'll have 60 over 120 minus 5h dh, and also multiply both sides by dt. So remember that on the right hand side we'll just have 1 once we divide, and then dt times 1 is just dt. So now we can integrate both sides, and the integral of the left hand side is basically a len integration. So first we can just make the educated guess that this is basically 120, a len 120 minus 5h. So, and obviously h is positive, so in this case, and now we can differentiate this. When we differentiate, we get just minus 5 over 120 minus 5h. But remember that we want to get 60, so that means that we need to multiply this by minus 12, because the two minuses would cancel, and then we'll have 12 times 5, which is 60. So therefore here must be minus 12 len 120 minus 5h, and that is equal to t plus c. So that's just the integral of the right hand side, because here we just have 1 dt. Okay, so at this point we can use the initial condition to find the constant of integration. So when t is equal to 0, h is equal to 6. So that means when h is equal to 6, we'll have len 120 minus 30, and we also have basically minus 12 here, is equal to t0, so it's just equal to c. And this is basically the value of c, so minus 12 len 90. Now rewriting the equation again, so the full form of the equation is minus 12 len 120 minus 5h is equal to t minus c, and c is now basically 12 len 90. Okay, so finally we want to find a value of t when h is equal to 10. So we just substitute h is equal to 10 here. We'll have minus 12 len, so 120 minus basically 50, which is 70. And then here is just 12 minus t minus 12 len 90. Right, so at this point we can basically rearrange this. So minus 12 len 70 plus 12 len 90 is equal to t, and this can be written as 12 len 9 over 7 using the property of logs, because this can be written as 12 len 90 over 70, and then that can be simplified to 9 over 7. So that's the value of t.